Well, Mrs. Gregory, it has been a long week of introductory quantum mechanics.
Oh, yeah.
And if students think that we don't know how it feels to finish a long week of school, they're wrong.
Yeah, we know. So we're starting off on the test hints for Chapter 5, Part 2. So
Part 2.
you're looking at the second half down here.
No
And
bottom.
you all have copies of this. You did a great job getting through the first half of the chapter. Remember, we wanted to divide this up so that you weren't getting too much intense information all at once. And when we were setting up for our little video extravaganza today, we realized that all of our props are going to fall off of here in a second.
Yeah.
So we're going to take a little break in the whole flow of things, and just Mr. Sustin will explain briefly what these all represent.
You might want to mark down the time so that you know how far to rewind back through the podcast. So these are orbitals. They are models, obviously, of orbitals. Someone went through great care to sculpt out of styrofoam three-dimensional models of the orbitals that the electrons occupy. It's sort of...
I have a curious question.
Yes.
When you were a student here,
Yes.
and you were a lab assistant,
Yes.
were you the one that built these?
I carved mine out of stone.
Out of stone?
Yeah.
Oh, way back then. We didn't have styrofoam back that far.
Yeah.
Okay, sorry. Go
So
ahead.
these are supposed to represent the motions of the electrons around the nucleus at different energy levels out from the nucleus. And I think we can all appreciate, we've all seen Bohr's model, that as you move away from the nucleus, you're occupying more and more space. So there are more and more electrons that can fit into those spaces. And if you plug some numbers into, is it de Broglie's equation or is it Schrodinger's equation? If you plug some numbers into Schrodinger's equation, you don't get lines, you don't get individual points to identify where an electron is. You get shapes, which is some pretty interesting mathematics.
And I think if they remember back to the first activity they did in this section where they're dropping the marble,
Yes.
and how those dots ended up when they fell on that target sheet, it wasn't like every dot ended up right in a nice neat circle on Bohr's model. They were kind of all over, but they were also in similar locations. There was a pattern developing there. And if you put a bazillion dots on the paper in 3 dimensions, you would get some shapes that look like these. So we
The
have
S orbital, the S sublevel, is spherical.
how convenient.
Some things in science make sense.
Right.
The P sublevel actually consists of 3 different orbitals oriented along 3 different axes, X, Y, and Z, coming out at you, a little 3D.
So we have one that lines up on the X, one on the Y, and one on the Z. And we've got them kind of tilted here on the board, but they should be lining up in all 3 dimensions.
You'll be able to see them live in class and check them out. But the P sublevel actually has 3 different orientations. P for peanut.
Peanut, right. I
they-
mean, there's a real name, principle, but whatever.
Yeah.
Peanut, they're peanut shaped. We go with that.
And then we have D. The D orbital system has 5 different orbitals, and we call them, if you look at these, and then look at these, you could twist your brain and say, these are double peanut.
Twice as many.
Yeah. And then we have F. And F is 7 different orbitals, and they are very, very difficult to model. And nobody over the 50 years, 60 years of West Geauga High School history,
West Geauga, 1950 established.
no one has taken it upon themselves to attempt to construct models of F orbitals.
But there are some links that we have on the webpage that show you that computer drawn, and you can actually layer them over each other and see how all these things would fit together. Imagine if you put all of these mushed together around one axis. Then we can see where we get overall this fuzzy cloud, which is what we know the atoms look like. But within that fuzzy cloud, there are these general areas, what did I say?
And
we're
there you
gonna knock
have
them
it.
off the board, that show up. So
Okay.
we wanted to do that before this happened.
All right, break.
Okay.